Hello, this is Dr. James Camp at Lee College in Baytown, Texas, and this is another of Camp's C++ Quickies. Today we're going to be talking about strings. Um, to put you in mind of what a string is, remember what we've talked about in the past about arrays and um, vectors. Okay, an array is a set of memory boxes set aside at usually at runtime, usually at compile time, uh, to have a certain number. So, for example, int myArray bracket 7 would set aside uh, spaces 0 through 6 here, which would be 7 spaces uh, for data. 7 spaces in this case for integers. And you can refer to any one of them using a subscript index. myArray bracket 5, or myArray at 5 as it's sometimes pronounced, would point to actually the sixth index, the sixth member of the array, which is index 5, because arrays are indexed starting at 0. Okay. A vector is sort of like an array with an object boxed around it. Okay. And that object manages the size of the array so that if you ever outgrow the space, you can add more. And in fact, usually when you allocate an array, it allocates more space. I mean, when you allocate a vector, it allocates more space than you actually needed or actually asked for. So if I had asked for this vector of int to be of size 7, or if I had provided 7 values in an initializer setup, this is what I would get. I'd get 7 filled memory boxes and then a certain number of extra empty ones, because the system is expecting that if I'm using a vector, I probably want to add to it at some point. If I keep adding and overflow the 4 empty memory boxes it's set aside, then it will reallocate the entire array to be even bigger and copy this array over to that new array, and now the vector will point to the new array. Again, my vector bracket 4, or my vector dot at 4, we add dot notation because my vector is an object, will point to, in this case, the 5th element in the array, which we've set up as 98. Okay. Why am I mentioning this when we're supposed to be talking about strings? Well, the reason that I am mentioning this is that a string works very much like an array. It is, in fact, an array of characters. So there are 2 types of strings. There is a C string, okay, and a C string is not a type. You can't say C string blah. What it is it is a character array say character my string of, say, 5. Okay. What that does is it sets aside an array of 5 characters. Boop, 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 boop. Okay. And I can assign that, say, M-I-K-E, Mike. And the last character is always a null character. And that tells C and all of the C string routines where to find, where the string ends. Because we don't usually know exactly how big this array is going to be when we start out. Okay, maybe we want character maybe we want to store the name of the user's city, and we set aside, say about 40 characters for that, because we can't think of any cities that have more than a 40 character name. Okay, there probably are somewhere in the world, but I can't think of any American cities that have more than a 40 character name. So in that case, we'll set aside a long array of characters here. One, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it just kind of keeps going, right? All the way on to 40. Now let's say we input the user's city, and it is Houston. Houston. Now when I go to write that string out to the screen, I don't want to write the contents of all 40 memory boxes that I've set aside here. So we put a null character, which is character \0. Okay, it's not the actual number 0. Let's see if I can write that a little better here. \0. Okay. That still looks awful. You get the point. It's a 0. And that is called a null character. It is a non-printing character ID number 0. Okay. It is not the character for the number 0. It is a null character. And so when I then go to print out city, if I did cout city, it would print Houston, and then it would see the null character and stop. Okay. So that is a C string. They are terribly painful to work with because you have to maintain that null character and not overflow the size of the string when you're doing any number of operations. If I were to replace this with Austin, I would come here and change this to an AUSTIN. And if I forget to move the null character, then this in will stay there. And when I print this out, it'll print Austin with an extra in there. So I can't do that. I have to remember to put that null character in. Okay. There are a whole series of library routines in the C string library that let's go look at those for a second. If we go to the C library, there's uh, a library called C string or string.h, um, and it has string copy, str in copy, which copies in characters from the string, string cat, concatenate strings. So you take a destination string and a source string and you add source to destination to make the string longer by adding to it. Um, there's string compare, which will compare two strings. You can't just put C string 1 equals C string 2, or equals equals. Uh, there are strlen, which will get the length of the string by counting where the position of that null terminator is and then subtracting 1 from that. Um, you can string token. You can split the string into tokens, locate a substring, um, locate the first or the last uh, location of a character in the string. So there are a number of useful um, number of useful uh, yeah, sorry. There are a number of useful functions that you can get for playing with C strings from the C string library. Why would you want to use a C string? Well, there are a number of older database softwares out there that require, um, say, the name of a city to be no more than 40 characters because that's how much they have allocated space for that particular string. And this is how they store them. And so you may need to use a C string to make sure that you're not overflowing a particular number of characters. Um, or if you ever find yourself programming an old-fashioned C without the plus plus, as I have for my courses this summer and fall in computer science, you may find yourself having to work with C, and those null terminators and everything become suddenly very important. For everything else, there is the string type in C++. So I can say string city equals double quote Houston semicolon, and it will create a memory location inside an object wrapper, just as it did for my uh, vector, and it will, just like for my vector, it will remember the size that I have assigned it, so I don't have to worry about those null terminators anymore. So I can just put H, O, U, S, T, O, N, 0, 1, 2, 3, 4, 5, 6. So size equals 7. That property is stored in this object wrapper. And so if I go see out city, in this case, it will go until it finds that it's exhausted the right number of characters, and then it'll stop, and it won't print these empty characters that I have left as padding. There are a few other string functions that we can use. If we come over to our C++ um, standard library, the string class, there's the string class itself, and there are a number of conversion functions. S to I is probably the most useful, string to integer, or S to D, string to double, or toString lets you pass in it's a highly overloaded function, so you can pass in an integer, a long, an unsigned, a float, a double, a long double even, and it will um, turn those numbers into strings. So if you have numerical data and you want to add it to a string, you can do that. If you have string data and you want to convert it to an integer, you pass the string. You can pass an index with where the number part of the string starts. So if you know that um, it's not, uh, if you know that your number doesn't actually start at the beginning of the string, you can pass in that it starts at index 3 or something like that. And then you can even give it a base. So you can convert from a numerical hex code like you use in specifying colors in HTML by specifying base 16. Okay. The string class itself has a whole lot of interesting functions. Um, the most important is that you can use the operator equals to assign strings. String 1 equals test string, string 2 equals x, string 3 equals string 1 plus string 2. Okay, so we don't have to use this strcat like we would with the C string. We can just add them using our usual operators. There's even a plus equal operator where we can say John plus equals K plus equals Smith plus equals even a new line character, and so the output would be John K. Smith and a new line. Okay. The operator bracket and the at function, just like we had in, you can say string bracket I to get the correct letter, or you can string dot at I to get the letter you're thinking of. You can append to a string, which is the same as the plus equals. You can push back to add one character at a time, pop back to take away one character at a time, just like with a vector. Assign is like using the equals operator. You just assign a new content to the string. You can insert. Now, this is a useful thing. If you know what position you want to start at, like if you had John Smith and you wanted to insert John Smith's middle initial, you could specify the position where you want to insert it and the substring that you want to insert. You can erase an entire string. You can erase a character from a string, which by default, if you just use erase, I think it clears the entire string, but you can also specify a starting position and an ending position and get rid of those characters. You can copy a string. You can, perhaps the most useful functions in this library, you can find content in a string, find the first of, the last of, the first not of, or the last not of. And with these, you can specify a whole set of characters. So if you want to find the first vowel, you put A-E-I-O-U in quotes and say find first of, and it'll return the first vowel in your string. You could do the same with first not of. You could find the first consonant in the string by saying first not of A-E-I-O-U. Okay. So that's all I'm going to talk about with this. Oh, and there's one other um, thing that's worth noting. There is a C string member function of a C++ string. So um, I can get my C++ string, please split this sentence into cogons, dot C underscore str parens, C string, and it will return the C string equivalent. So you can use it with all of those C string functions we talked about earlier, like the string token string splitter uh, function, which is useful for processing data. If you have somebody entering a number of different words and you want to split out each word by finding spaces, you can do the string token and use the space character as a search token. Okay. So that's all I'm going to do with this one today. I'm not going to write any actual code because um, we've written code using strings before. So I'm just going to leave it at that as kind of an overview of how strings and C strings work. And we'll write some more code using them later.